Hello my friends and welcome back to the You Can Do TV channel. Belaz, short for Belarusian automobile plant, has been a titan in the production of heavy-duty dump trucks for over 6 decades. Established in 1948 in Zhodino, Belarus, Belaz initially focused on producing agricultural equipment and construction machinery. However, it wasn't until the late 1950s that the company shifted its focus towards manufacturing mining dump trucks, marking the beginning of its remarkable journey in the heavy machinery industry. The hallmark of Belaz's production line is its dump trucks, which are some of the largest and most powerful in the world. These behemoths are essential in the mining industry, where they are tasked with transporting immense quantities of earth, rock, and minerals from mining sites to processing facilities or dumping areas. The sheer size and capacity of Belaz dump trucks make them indispensable in large-scale mining operations across the globe. One of the defining features of Belaz dump trucks is their colossal size, often compared to the height of a 3-story building. These trucks can tower over conventional vehicles, showcasing their dominance on mining sites. The immense height of Belaz dump trucks not only provides them with a commanding presence but also enables them to carry enormous payloads, ranging from hundreds to thousands of tons, depending on the model. From the wheelbase to the cab height, every aspect of a Belaz dump truck is engineered to meet the rigorous demands of mining operations. The design incorporates robust materials and heavy-duty components to withstand the harsh conditions of mining environments, including extreme temperatures, rough terrain, and heavy loads. Additionally, advanced suspension systems ensure stability and maneuverability, allowing these mammoth machines to navigate challenging landscapes with ease. Belaz dump truck production requires state-of-the-art manufacturing facilities equipped with advanced technology and machinery. The production process involves a combination of precision engineering, automated assembly lines, and skilled craftsmanship to ensure the highest quality standards are met. From welding and machining to painting and final assembly, each step in the manufacturing process is meticulously executed to produce reliable and efficient dump trucks. Over the years, Belaz has continuously innovated and upgraded its dump truck models to meet the evolving needs of the mining industry. The company invests heavily in research and development to incorporate the latest technologies and engineering advancements into its products. This relentless pursuit of innovation has enabled Belaz to stay ahead of the competition and maintain its position as a global leader in dump truck manufacturing. One of the most significant milestones in Belaz's history came with the introduction of its ultra-heavy-duty dump trucks, capable of lifting payloads of up to 450 tons. These massive machines represent the pinnacle of engineering excellence and are instrumental in tackling the most demanding mining projects worldwide. With their unparalleled lifting capacity and unmatched performance, Belaz's super-heavy dump trucks have set new benchmarks in the industry. Beyond their impressive technical specifications, Belaz dump trucks play a vital role in driving economic growth and development in Belarus and beyond. The company's operations support thousands of jobs, both directly and indirectly, contributing to the livelihoods of individuals and families in the region. Furthermore, Belaz's export of dump trucks to countries around the world enhances Belarus's reputation as a hub for heavy machinery manufacturing and strengthens its presence in the global market. Welcome to the future of tire manufacturing at the Double Coin Commercial Tire Plant in Rayong Province, Thailand. Let's start at a nearby rubber tree plantation. Workers here employ a traditional yet effective method of collecting natural rubber. Each tree is delicately scored, allowing the milky liquid to accumulate in small balls, preserving the integrity of the raw material. The process begins with the mixing of raw materials to form the rubber compound. Computer systems, overseeing every step, contain recipes of natural and synthetic rubber, carbon black, sulfur, and other chemicals. The resulting rubber batches are transformed into thick sheets through powerful rolling mills, laying the foundation for tire production. With robotics and advanced automation, this plant operates at full capacity with only 500 people, a stark contrast to the 2,500 employees a few years ago. The efficiency achieved translates to approximately 4,100 truck and bus radials and 136 off-road radials daily, ensuring consistent high-quality tires for double coin customers. The tire-making process commences with the assembly of profiled rubber bands into sturdy steel-reinforced bead rings, crucial for securing the tire on the rim. Advanced automation seamlessly handles the assembly, processing 10 tons of rubber every hour, a feat unimaginable just a few years ago. Moving forward, the green tire assembly begins, involving the layering of sidewalls, main tread rubber, steel belts, and fabric. The tire building machine binds these components together, ensuring proper adhesion through heat and rotation. The green tire is then transported to a refrigerated holding area until it undergoes the final curing process, controlled by computers to achieve optimal results. In the curing press, the green tire is subjected to great heat and pressure, molding it into its final shape and tread pattern. The fully formed tire undergoes rigorous inspection for uniformity, balance, symmetry, and overall quality. Precision is paramount. Even the roundness of the tire is closely monitored, as the smallest variation can impact tread wear and vibration. Upon passing inspection, each tire is laser etched with a unique serial number. The completed tires are organized in the fully automated warehouse, ready for transport to double coin dealers worldwide. Hofmann's wheel assembly line is a state-of-the-art automated production system designed to meet the high-quality standards of the automotive industry. From initial planning to the start of production, they provide turnkey solutions for wheel assembly, offering semi-automatic, fully automatic, and robot-assisted systems. The assembly lines are characterized by precision and innovation, making Hofmann a leading manufacturer in the sector. With years of experience and expertise, the company has developed a comprehensive range of products that cater to the assembly and testing needs of complete wheels. These lines impress with their excellent precision and operate seamlessly through a fully automatic process. Hofmann's wheel assembly line is a state-of-the-art automated production system designed to meet the high-quality standards of the automotive industry. The automatic tire inflator is designed for precision tire inflation, independent of rim design. The automatic bead seat optimizers utilize radially arranged load wheels to apply lateral and/or radial forces to the tire sidewall, optimizing the tire bead seat on the rim. Accurate measurement of imbalance and tire uniformity requires a properly seated tire bead. The wheel uniformity measuring machines serve the dual purpose of checking tire uniformity and the overall uniformity of complete car wheels. By measuring force fluctuations and static force reactions in radial and lateral directions under load, the fully automatic two-plane wheel balancing machines, type AWS, are designed for measuring static and dynamic imbalances in complete car wheels. These machines accommodate both unbalance correction measurements and unbalance control measurements, detecting unbalance in batch or mixed mode operations. Calibration is achieved through a basic adjustment and the AWSR variant. The manual correction stations, typically integrated with wheel balancing machines, assign unbalance values and correction positions to wheels. The employee is guided through the correction process, with weight information displayed on a screen. Various weights, including adhesive weights, two-part safety weights, or impact weights, can be processed. Automatic weight application with robot for adhesive weights and two-piece weights. Fully automatic correction stations from Hofmann can be seamlessly integrated into wheel balancing machines or installed independently with a dedicated control system. The retreading tire industry is a critical player in the global market, providing a cost-effective and environmentally responsible solution for extending the lifespan of tires. The process involves refurbishing spent tires by applying new treads onto their existing casings after a thorough inspection and repair. This practice preserves approximately 90% of the material in spent tires, with the material cost being only about 20% compared to manufacturing new ones. The tire retreading market has seen significant growth, driven by economic and environmental considerations. It is a sustainable solution that reduces the demand for new tire production, minimizes waste, and addresses sustainability concerns. From an economic perspective, retreading offers substantial cost savings, particularly for industries heavily reliant on vehicles, such as transportation and commercial fleets. As of 2020, the tire retreading market was valued at $9.02 billion and is projected to reach $12.36 billion by 2028, growing at a CAGR of 4.0% from 2021 to 2028. This growth is indicative of the increasing adoption of retreaded tires across various sectors. Advantages of retreading tires. Cost savings. Retreading provides a budget-friendly alternative, with substantial cost savings compared to purchasing new tires. Environmental impact. Retread tires significantly lower the volume of raw materials required for new tire manufacturing, including a substantial reduction in oil usage. The US EPA estimates over 75% savings in oil used for a retread compared to a new tire. Waste reduction. Retread tires contribute to minimizing the amount of waste in landfills. This is crucial, given the significant number of waste tires dumped into the municipal solid waste stream. Challenges and safety concerns. The National Highway Traffic Safety Administration, NHTSA, acknowledges concerns about the safety of retread tires, especially for heavy vehicles. Research is ongoing to determine the proportion of tire debris from retreads compared to new tires and to understand the causes of tire failure and related crash safety issues. Government support and regulations. The tire retreading industry receives support from government initiatives. Federal Executive Order 13,149 encourages the use of retread tires for economic and environmental efficiency, particularly in federal vehicles. Environmental impact. Retread tires not only reduce the need for raw materials but also contribute to a significant reduction in greenhouse gas emissions. A single car tire, which consists of 40% natural rubber and 60% oil-based rubber, can achieve substantial savings in natural rubber through the retreading process. The manufacturing process of rubber tracks begins with the thorough cleaning of the steel components to remove any rust, dirt, or contaminants. Specially treated steel cables are prepared for the inner structure of the rubber track. The rubber material, which forms the outer layer of the rubber track, undergoes a cooling process. This step is crucial to achieve the desired properties and performance of the rubber. The cooled rubber material is then prepared and cut into various sizes based on the specifications of the rubber track to be produced. The assembly process involves placing the steel components and treated cables in the correct order to create the internal structure of the rubber track. Special attention is given to ensure that the steel cables do not overlap, maintaining the desired flatness. The surfaces of the rubber track undergo coating with a special treatment. This treatment enhances the overall durability and performance of the rubber track. Rigorous quality control checks are conducted at various stages of the manufacturing process. This includes checking for any defects, bubbles, or imperfections in the rubber track. The final assembled tracks are inspected for dimensional accuracy and overall quality. The finished rubber tracks undergo a comprehensive final inspection. This involves checking for any minor cracks, bubbles, or inconsistencies. Once the rubber tracks pass all quality checks and tests, they are prepared for packaging. The Prozax first-stage tire building machine is a sophisticated system comprising three key components: tire building drum turret servicer, Positioned in the upper location, it optimizes floor space and capital expenditure. Allows for simultaneous ply feeding, minimizing downtime during material wind-up and building drum operations. Programmable logic controller and operator's control panel. The machine operates at an impressive 110 revolutions per minute, driven by a double shaft. The operator's control panel, conveniently placed within the operator's reach, provides detailed information and allows adjustments for machine functions and building recipes. The Prozax first-stage tire building machine features a robust control system ensuring precision and efficiency in tire production. The integration of advanced control technology ensures seamless operation and high-quality tire manufacturing. Control panel. The operator's control panel is the command center for the tire building process. Positioned for easy access, it provides detailed information about the actual specifications, allowing the operator to make adjustments to machine functions and building recipes. It also serves as an alert system, notifying the operator of any incorrectly set up parts. The machine is equipped with several sets of stitching rollers, both for lower and upper stitching. These rollers play a crucial role in ensuring perfect adhesion of different carcass ply layers, strips, and various materials, contributing to the overall quality of the tire. Bead setting is a critical step in tire building, and Prozax's first-stage tire building machine excels in this aspect. The machine is equipped with bead setting rings that are pneumatically driven, ensuring maximum precision during the fitting of beads. Linear guides enable accurate and consistent bead placement. In the second stage of tire production, Prozax's tire building machine continues to showcase its advanced features, ensuring a seamless and precise tire building process. The transferable shaft and disc plates play a crucial role in facilitating the carcass shaping process. They allow for the easy transfer of the green tire from the first stage, positioning it onto the disc plates for further processing. The stitching facility in the second stage is essential for the proper adhesion of breakers and treads onto the carcass. This unit ensures that the rollers move in 3 different directions, enabling comprehensive stitching operations. This meticulous approach prevents the trapping of air, contributing to the structural integrity of the tire. Breakers are fed into the tire building machine from a specialized servicer. The servicer is designed to accommodate breakers with a maximum width of 900 millimeters. This component ensures that breakers are precisely placed during the tire building process. The strip winder, an integral part of the tire building machine, is responsible for applying the tread. This process involves carefully winding strips around the green tire, contributing to the overall structure and functionality of the final product. After the transfer of the green tire, the carcass shaping process takes place. This step involves inflating and shaping the carcass to meet the specified dimensions. Precision is paramount, and Prozax's tire building machine excels in achieving the exacting standards required in tire manufacturing. Similar to the first stage machine, the second stage tire building machine is equipped with highly sophisticated control systems from leading German technological companies. Automation is a key feature, ensuring that most processes run automatically, reducing the margin of error and enhancing overall efficiency. In addition to the strip winding process, the machine offers a modification for extruded tread application. The Schenck tire and wheel assembly line operates with precision and efficiency through a series of well-defined steps to ensure the production of high-quality and balanced complete wheels. The key steps in the assembly process include rim soaping and TPMS indexing, automatic weight application using endless weights, unbalanced compensation with adhesive and clip weights, and a specialized process for unbalanced compensation with two-piece clip weights. Rim soaping and TPMS indexing. The process begins with the transportation of tires and rims to the mounting station. In parallel, rim soaping occurs, involving the application of a mounting agent on the tire bead and rim flange. This is a critical step to facilitate the smooth assembly of tires onto rims. TPMS, Tire Pressure Monitoring System, indexing is also performed during this stage, ensuring that the tire pressure sensors are accurately positioned and integrated into the wheel assembly. The Ventuo mount assembly machine provides maximum performance and flexibility for your complete wheel production in the working range 15-24. The type-specific assembly process allows a gentle tire assembly at shortest cycle times. The high performance of the system is equally available in batch or sequence mode. The corrosion-resistant stainless steel soap stations provide optimal process reliable application of the mounting agent on tire bead and rim flange. Automatic weight application using endless weights. Automatic weight application is a crucial step in achieving a balanced wheel assembly. Endless weights are applied to the wheel automatically, taking into consideration factors such as tire size, rim type, and other specifications. This step ensures that the wheel is properly counterbalanced, contributing to overall vehicle safety and performance. Unbalanced compensation with adhesive and clip weights. Unbalance is a critical factor that can lead to vibrations and affect the vehicle's performance. The assembly line addresses unbalance by compensating with a combination of adhesive weights and clip weights. Adhesive weights are precisely attached to specific locations on the wheel to counteract any imbalance, providing a tailored solution. Unbalanced compensation with two-piece clip weights. In addition to the standard clip weights, the assembly line incorporates a specialized process for unbalanced compensation using two-piece clip weights. These two-piece clip weights offer a more customizable and fine-tuned solution for achieving balance in the wheel assembly. Sierra International Machinery's REB22 Ram Baler stands as an epitome of efficiency in high-volume recycling facilities. With an impressive 254 tons of shearing, baling force, this machine is designed by recyclers for recyclers. Its adaptability is showcased through a choice of 150 or 250 HP power units, ensuring versatility in processing various materials at an elevated production rate. The REB2's unique shear blade caters to waste, fiber, non-ferrous scrap metal, and tires without compromise. In action, the machine demonstrates innovative features like an oversized bale release door and full ejection, minimizing material contamination during material changes. The robust frame, fortified with 1/2 Hardox 450 replaceable liners, can withstand high hydraulic pressures, making it energy efficient and highly productive. The REB2 excels in handling diverse recyclables. In the dynamic realm of tire recycling, the tire shredding machine stands as a stalwart player, undertaking the pivotal task of transforming discarded tires into a more manageable and recyclable form. This ingenious device operates through a systematic process designed to efficiently dismantle used tires, contributing significantly to environmental sustainability. The tire recycling journey begins as used tires are ushered into the tire shredding machine, either excavators or through the seamless integration of a conveyor belt. Some machines boast a pre-shredder component, which meticulously slices the tires into smaller, more manageable sections before their entry into the primary shredding chamber. Within this main arena, the heart of the tire shredder, sharp rotating blades or hammers tirelessly engage with the rubber, tearing and shredding the tires into smaller, more manageable pieces. This process serves a dual purpose, reducing the volume of the tires and preparing the rubber for subsequent processing. Post-shredding, the material undergoes a screening and separation phase. A screen facilitates the segregation of rubber from other tire components such as steel wires and fabric. To further refine this separation, magnetic separators come into play, deftly extracting steel wires for subsequent recycling. The meticulous nature of this separation ensures that each constituent part can be harnessed for further use, optimizing the recycling potential of discarded tires. The output of this tire shredding process comprises shredded rubber, now in a more manageable and versatile particle size. This shredded rubber finds application across diverse industries, whether as crumb rubber for playgrounds or sports surfaces or as a valuable component in the creation of asphalt. Simultaneously, steel wires, having been efficiently removed, embark on their own recycling journey through smelting and processing. Tire protection chains, also known as tire protection chains in some regions, are specialized chains designed to safeguard the tires of heavy machinery operating in demanding environments such as mining, quarrying, construction, and forestry. These chains are particularly vital for large vehicles operating in rough terrain, where the risk of tire damage from sharp rocks, abrasive surfaces, and heavy loads is significant. The primary purpose of tire protection chains is to extend the lifespan of tires and minimize downtime and maintenance costs associated with tire replacement. By providing an additional layer of protection, these chains effectively shield the tire tread and sidewalls from punctures, cuts, and abrasions, thereby enhancing overall equipment performance and safety. Tire protection chains typically consist of high-strength alloy steel links interconnected to form a durable mesh-like structure. The chains are designed to wrap around the circumference of the tire, covering the tread area and extending onto the sidewalls to provide comprehensive protection. Each link in the chain is engineered to withstand extreme forces and resist wear and tear, ensuring long-term reliability in harsh operating conditions. To further enhance the performance and durability of their tire protection chains, Pewig introduced cryogenic treatment, a pioneering step in the industry. Cryogenic treatment involves subjecting the chains to extremely low temperatures, typically around -80 degrees Celsius, following conventional heat treatment processes. This additional step results in a notable increase in the chain's strength and resilience, bolstering its performance by an impressive 10%. While this advanced treatment does incur additional costs, Pewig remains focused on delivering value to customers by considering the long-term benefits in terms of cost per hour of operation. Notably, Pewig stands alone as the sole company in the industry to offer cryogenically treated tire protection chains, underscoring their commitment to innovation and excellence. By pushing the boundaries of technology and manufacturing processes, Pewig ensures that their chains set the standard for strength and durability in the demanding environments of open-pit mining operations. The operation of tire protection chains is relatively straightforward but highly effective. When installed properly, the chains form a rugged barrier between the tire and the terrain, absorbing impact and distributing pressure evenly to prevent localized damage. Here's how tire protection chains work. Installation. Tire protection chains are fitted around the circumference of the tire and secured in place using fastening mechanisms such as tensioning hooks or locking devices. Proper installation is crucial to ensure the chains remain securely attached during operation. Protection. Once installed, the tire protection chains act as a protective shield, covering the tire surface and deflecting hazards such as rocks, debris, and sharp objects. The robust construction of the chains prevents punctures, cuts, and abrasions, preserving the integrity of the tire tread and sidewalls. Traction. In addition to providing protection, tire protection chains enhance traction and stability, especially in challenging terrain such as mud, snow, ice, or loose gravel. The chains bite into the surface, increasing grip and reducing slippage, thereby improving vehicle control and maneuverability. Wear resistance. Tire protection chains are engineered to withstand continuous use in rugged environments without succumbing to premature wear. High-quality materials and precision manufacturing techniques ensure that the chains maintain their strength and durability over extended periods of operation. Maintenance. Regular inspection and maintenance are essential to ensure the optimal performance of tire protection chains. This includes checking for signs of damage, wear, or corrosion, as well as adjusting tension and lubricating moving parts as needed. Proper maintenance helps extend the service life of the chains and ensures uninterrupted operation. The Baler 75710 commands attention with its sheer size, standing tall at a height comparable to a three-story house. Its colossal dimensions, measuring 20.6 meters in length, 8.16 meters in height, and 9.87 meters in width, make it one of the largest vehicles ever constructed. The towering presence of its wheels, exceeding the average height of a person, further emphasizes its monumental scale. The Baler 75710 isn't just about size, it's about muscle too. With a jaw-dropping payload capacity of 450 tons, it surpasses its contemporaries by a considerable margin. Despite its massive frame, its relatively shallow bed doesn't compromise its ability to carry vast quantities of material. Whether it's ore, rock, or other bulk materials, the truck tackles the task with ease, making it indispensable in mining and construction operations. At its core, the dump truck adheres to a conventional two-axle configuration, albeit with a distinctive feature: doubled wheels per axle reminiscent of the 1950s International Payhauler 350. This design paradigm provides the requisite stability and load-bearing capacity essential for handling its mammoth payloads. Powering the Balers are two MTU 65-liter 16-cylinder 4-stroke diesel engines, each generating a formidable 2,300 horsepower. This results in a combined output exceeding 11,000 horsepower, facilitating unparalleled acceleration and traction capabilities. The utilization of two engines provides redundancy and operational flexibility, enabling the truck to function optimally even under varying load conditions. The Siemens MMT 600 drive system, a hallmark of innovation, harnesses the power generated by the diesel engines, driving two AC alternators. These alternators, in turn, supply electricity to four AC traction motors, with two motors allocated to each axle. This distributed power delivery mechanism ensures optimal torque distribution, enhancing traction and maneuverability across challenging terrains. In terms of performance, the dump truck surpasses expectations with a claimed maximum speed of 64 km per hour. Furthermore, its economy maximum speed of 40 km per hour, achievable when fully laden and traversing a 10% gradient, underscores its efficiency in real-world operational scenarios. The truck's agility is further exemplified by its turning radius of approximately 31 meters, facilitated by its four-wheel hydraulic steering system. This feature enables precise maneuvering, essential for negotiating tight spaces within mining and construction sites. Fuel efficiency, a critical consideration in heavy-duty applications, is addressed with a consumption rate of 198 grams per kilowatt-hour. Moreover, the option to operate on a single engine when carrying less than full capacity loads optimizes fuel utilization, minimizing operational costs without compromising performance. Safety remains paramount in the design of the Baler, with several features implemented to mitigate risks associated with its size and operational environment. An automatic fire suppression system ensures rapid response to potential fire hazards, safeguarding both the vehicle and its cargo. Additionally, Surveillance camera systems enhance situational awareness, enabling the operator to monitor the vehicle's surroundings effectively. The driver's cabin, though modest in size compared to the truck's dimensions, prioritizes ergonomic design and functionality. Accommodating up to 2 occupants, the cabin ensures optimal comfort and control, facilitating extended operational periods without compromising operator well-being. Furthermore, noise levels within the cabin are maintained below 80 decibels, akin to the ambiance of a large hall, ensuring a conducive working environment without the need for excessive protective gear. Since its introduction in 2013, the Baler has revolutionized the landscape of heavy haulage, setting new benchmarks for size, power, and efficiency. Its deployment in mining and construction operations worldwide has facilitated cost-effective transportation of bulk materials, enhancing productivity and operational efficiency. The Baler 75710 continues to hold its position as the world's largest haul truck according to the Guinness Book of Records. As a symbol of technological prowess and industrial ingenuity, the truck remains unrivaled in its class, leaving an indelible mark on the heavy equipment industry. MTB, a leading player in tire recycling, employs a meticulous process to transform discarded tires into valuable materials. The journey begins with the shearing stage. At the heart of this stage is MTB's CRX 2000 shear, a rotary shear designed with innovation and user-centric features. This equipment boasts a unique design and cutting power, making it capable of handling a diverse range of challenging waste materials, with a particular focus on tires. The CRX 2000 shear is equipped with cutting blades that are not only highly effective but also easily interchangeable, providing operational flexibility and cost-effectiveness. This feature allows for swift adaptation to different types of waste, ensuring a smooth and continuous processing flow. The shear's high cutting power enables it to shred various tire types, including car and truck tires, as well as large off-the-road (OTR) tires with diameters of up to 2.2 meters. Operating in rotor shear mode, the CRX 2000 shear demonstrates impressive throughput, handling between 15 to 20 metric tons per hour. This capability makes it suitable for large-scale tire recycling operations, contributing to the efficiency of the overall process. Following the shearing stage, the iron fraction is extracted through a sophisticated magnetic separation process. The TMR magnetic separators play a crucial role, featuring a horizontal conveyor with a shaking assembly beneath the belt and a permanent overband magnet above it. This combination effectively removes steel pieces from the product, enhancing the overall recycling efficiency. The system's flexibility allows adjustment according to the specific product being processed, ensuring optimal separation. Additionally, the inclusion of a thumper beneath the conveyor belt strategically positions the product for efficient sorting. Moving to the sorting stage, MTB utilizes air density tables for a thorough and precise separation of granulated materials based on size, shape, and weight. The air fluidized bed and sloping vibrating table combination facilitates the separation of rubber big fraction, rubber light fraction, and textile materials. This process is essential for achieving a clean and sorted output. MTB's air density tables are not only effective but also environmentally conscious, with a dust collection system in place to minimize emissions. The tables excel in separating various materials, from metals to plastics and heavy metals to light metals. Their Destiner style ensures accurate sorting without the need for rerunning middling fractions, providing stability and minimizing the need for constant adjustments. MTB offers a range of advanced solutions for tire treatment, including the manufacturing of tire-derived fuel, TDF, with or without steel, complete granulation lines for producing 0 to 4 mm aggregate, granulate refining for 0 to 1.5 mm particles, textile cleaning system, TCS, for high-yield clean textiles and rubber, and the clean wire system, CWS, for obtaining exceptionally clean steel, reaching up to 98% purity depending on selected parameters. Maris, an Italian manufacturer specializing in co-rotating twin-screw extruders, leads the industry in rubber devulcanization for end-of-life tires. Their patented thermomechanical synergic process, free from chemical additives, transitions vulcanized rubber to a non-cross-linked state. This innovative approach selectively breaks SS and CS bonds, achieving a devulcanization yield of 60 to 80%. The process accommodates various rubber types, from end-of-life tires to specialty elastomers. Chemical and rheological analyses reveal a devulcanization yield of 60 to 80%, with the potential to reuse 15 to 50% of the material for the original application. Melt spinning of polymers containing carbon nanotubes represents a cutting-edge process in the field of nanocomposite materials. This technique involves the incorporation of carbon nanotubes, CNTs, into polymer matrices through a melt extrusion process, resulting in enhanced mechanical, electrical, and thermal properties. During melt spinning, the polymer and carbon nanotubes are melted and extruded through a spinneret to form fibers or filaments. The process allows for the uniform dispersion of carbon nanotubes within the polymer matrix, leading to improved structural integrity and performance. Carbon nanotubes, with their exceptional mechanical strength and electrical conductivity, contribute to the overall enhancement of the composite material. The melt spinning method offers several advantages, such as scalability, cost-effectiveness, and versatility in producing fibers with tailored properties. The resulting nanocomposite materials find applications across various industries, including aerospace, automotive, and electronics. The incorporation of carbon nanotubes enhances the tensile strength, modulus, and thermal conductivity of the polymer, making it ideal for applications requiring lightweight, durable materials with superior electrical conductivity. As the field of materials science continues to evolve, melt spinning of polymers containing carbon nanotubes stands as a pivotal technique, driving innovation in the development of advanced materials for diverse technological applications. Mamanu Polyester Industries has embarked on a groundbreaking initiative to address the global issue of plastic waste by transforming unused plastic bottle residues into high-quality recycled polyester staple fiber, PSF. With a staggering 1 million plastic bottles being purchased worldwide every minute, and the projection of a 20% increase by next year, the need for sustainable solutions is more pressing than ever. In Bangladesh, where a mere 7% of collected plastic bottles were recycled last year, the majority ends up in landfills, rivers, and oceans, posing a severe threat to the environment. However, Mamanu is making a significant impact by collecting vast amounts of unused plastic bottles, primarily sourced by lower-income and underprivileged individuals. The recycling process begins with traders cutting and washing the collected bottles into PET bottle flakes. These flakes are then purchased by Mamanu, where they undergo a meticulous cleaning process in a hot water washing plant. The clean PET bottle chips are further processed through a series of steps, including vacuum drum drying to eliminate moisture. Melting process. Cleaned PET bottle flakes, now referred to as chips, are transferred to a melting unit. The chips undergo a series of steps, including boiling in vacuum drums to remove moisture, ensuring high-quality material. The moisture-free chips are then melted through a screw extruder. Spinning process. Melted material is directed to the spinning section, where it is further processed into a sliver resembling noodles. The slivers are collected into cans and progress through the SK reel stage, the first phase of the drawing section. Drawing and cutting. In the drawing section, the slivers are drafted in 6 steps using chemicals like lubricant and titanium dioxide. The outcome is 1-point denier primary fiber, which moves into a dryer for moisture removal. Moisture-free primary fiber is transferred to a cutting machine, producing PSF cut into buyer-specified lengths, e.g., 38 mm or 32 mm. In addition to the environmental benefits, the company envisions an annual revenue of $25 million, equivalent to 200 crore taka, signaling the promising economic prospects of sustainable practices. This journey towards a more environmentally friendly and economically viable future has already set a positive precedent in the country. The journey begins with the arrival of bales of raw wool at Woolrich's mill, a tradition that has endured since the days of John Rich. Dye house. Once the raw wool passes inspection, it moves to the dye house. This step adds a splash of color to the natural hues of the wool, a departure from the raw, earthy tones. Woolrich's commitment to customization is evident here, as the dyeing process can be tailored to meet specific design requirements. The vibrant colors not only enhance the aesthetic appeal but also contribute to the functionality of the final product. Blending. After dyeing, the wool undergoes blending, where different batches are mixed to achieve a uniform and consistent texture. This process ensures that the final fabric will have a balanced composition, both in terms of color and texture. The skilled artisans at Woolrich use their expertise to create blends that are not only visually appealing but also durable and versatile. Carding. The blended wool is then subjected to the carding process, a method that aligns and separates the fibers. This step plays a crucial role in preparing the wool for the subsequent stages of production. The result is a web of fibers that possesses the ideal qualities for crafting high-quality textiles. In the heart of Woolrich, Pennsylvania, a legacy of craftsmanship and dedication to quality textiles has been woven into the very fabric of the community. This tradition traces its roots back to 1830 when John Rich, the founder of Woolrich, constructed his first woolen mill in Plum Run. From the humble beginnings of a mule cart peddling fabrics to loggers, miners, rivermen, and trappers, Woolrich has evolved into a symbol of premium American fabrics. Today, 8 generations later, the commitment to producing superior textiles persists. Plying. Plying involves twisting multiple strands of carded wool together to create a stronger and more resilient yarn. This process adds durability to the fabric, ensuring that it can withstand the test of time. The attention to detail at this stage contributes to Woolrich's reputation for producing fabrics that are not only aesthetically pleasing but also robust and enduring. Winding. The plied yarn is then wound onto spools, preparing it for the weaving process. This meticulous winding ensures that the yarn is evenly distributed, laying the foundation for a consistent and well-structured fabric. Warping. Warping marks the transition from yarn to fabric. In this step, the yarn is arranged lengthwise on a frame, creating the warp, the foundation of the fabric. The precision and skill involved in this process set the stage for the weaving that follows, determining the strength and structure of the final fabric. Weaving. The heart of the manufacturing process lies in the weaving room, where the interlacing of the warp and weft creates the intricate patterns and textures that define Woolrich fabrics. The shuttle moves rhythmically, guided by the hands of skilled artisans who bring decades of experience to their craft. It is in this room that the essence of Woolrich's tradition is most palpable, as the looms resonate with the echoes of centuries of craftsmanship. Burling, mending. After weaving, the fabric undergoes burling and mending, a meticulous process where any imperfections or irregularities are carefully addressed. Skilled artisans inspect the fabric, correcting any flaws to ensure that only the highest quality textiles bear the Woolrich name. Washing. The woven fabric then undergoes a thorough washing process to remove any residual impurities and set the final dimensions. This step is crucial in achieving the desired hand feel and drape of the fabric. Drying. Following washing, the fabric is carefully dried, a delicate balance to maintain its integrity while ensuring it is ready for the subsequent stages of production. Final inspection. Before the fabric is deemed ready for use, it undergoes a final inspection. Finished fabric. The journey that started with bales of raw wool concludes with the creation of Woolrich's finished fabric, a testament to the enduring commitment to craftsmanship and quality. Gray goods, in the form of square bales or large rolls containing 120 to 250 yards of fabric, arrive at the print plant. Printed fabric production is a triad of fundamental steps: preparation, printing, and finishing. The initial phase of the preparation process involves singeing. Cotton gray fabrics tend to be hairy, and these unruly fibers must be removed before proceeding with other production steps. The fabric undergoes a singeing machine, where it is brushed to raise fibers and then subjected to a high-speed gas flame. This process burns off surface fibers, leaving the fabric considerably smoother. Following singeing, the fabric undergoes scalding, a chemical washing process aimed at removing natural wax and seed fragments from the cotton fibers. Boiled in an alkaline solution, usually sodium hydroxide, the fabric forms a soap. Oxygen exclusion during scouring is imperative to prevent weakening of the cotton fibers. The next step is desizing, a treatment that removes the added size from the fibers, essential for reinforcing the yarns and preventing breakage during weaving. Size removal is achieved through enzymes that break down starches and other agents used in sizing the yarns. Enzymatic desizing demands precise control of pH, temperature, and water hardness for optimal effectiveness. Even after scouring and desizing, high-quality cotton fibers may still appear yellowish. To achieve the pure white necessary for dyeing or printing, the fabric undergoes bleaching. Unlike household bleach, commercial cotton bleaching involves hydrogen peroxide and a series of baths with increasing concentrations and temperatures. Post-bleaching, the fabric is dried on heated metal rolls, emitting copious amounts of steam. The fabric emerges from this process significantly purer in color. The last steps in preparation, mercerization, and tempering, are conducted simultaneously. Mercerization strengthens cotton fibers, providing a lustrous appearance, while tempering stabilizes the fabric width. As the fabric progresses through these stages, the factory becomes a smoky and steamy environment, making visibility difficult and the air laden with chemicals. Washing the fabric of all residual chemicals and passing it through heated metal rollers marks the completion of the preparation process. The fabric, now prepared for printing, is ready for the next stage. Before delving into the actual printing process, a brief introduction to screens is provided. Two types of print machines, rotary and flatbed, employ different screens. While the intricate details of screen production are beyond the scope of this overview, understanding some aspects aids in comprehending the printing process. The fabric's journey continues in the print factory, where the color kitchen plays a crucial role in dye mixing and color matching, utilizing a computerized system. Finally, the focal point of the factory is reached, the area where the actual printing takes place. In this instance, a flatbed printing machine is showcased. The screens, rectangular and flat, measure 24 inches in height and span the fabric's width. The lengthy bed of the machine accommodates multiple screens. Positioned on a rubber belt, the fabric receives its first color as the screen, loaded with ink, moves across the fabric. The intricate dance of the squeegee, screen, and fabric results in the transfer of color onto the pristine white fabric. With each pass, the screen lifts, the squeegee moves back, and the belt advances by 24 inches, facilitating the printing of various colors. This mesmerizing process repeats until the fabric is adorned with the chosen design. The color, precision, and artistry of the printing process transform the once stiff and impure gray goods into vibrant, printed fabrics ready to be embraced by quilting enthusiasts worldwide. As we progress from one screen to the next in the captivating world of fabric printing, a vibrant transformation unfolds. The fabric, initially a pristine white canvas, begins to embrace an array of colors through a meticulous printing process. Guided by precision and artistry, each stage adds depth to the fabric, turning it into a masterpiece ready to be embraced by quilting enthusiasts worldwide. The journey through screens commences with black ink, creating the initial foundation. Subsequently, a splash of green is introduced, followed by a delightful infusion of pink. The fabric evolves with each addition, showcasing a harmonious trio of black, green, and pink. The magic continues as purple takes center stage, weaving through open areas on the screen. Dye is selectively pushed through these openings, adorning the fabric with the mesmerizing hue. Building on this symphony of colors, a lighter green is delicately applied, creating a dynamic interplay with the deeper shades. The journey unfolds with the introduction of a lighter pink, bringing forth a kaleidoscope of hues. With each screen, the fabric becomes progressively more colorful, gradually veiling the pristine white background. A third green makes its mark, followed by another appearance of the regal purple. Ensuring meticulous alignment of screens is paramount to avoid registration issues where colors bleed into one another or deviate from outlined patterns. Following the second purple, a bold red color makes its debut, adding a dynamic contrast to the evolving palette. Some screen stations are intentionally left vacant, a strategic choice for this particular print that doesn't maximize the machine's color capabilities. While intermittent drying elements are sometimes introduced between screens to expedite the process, this particular pattern gracefully proceeds without this requirement. The fabric's transformation continues with the introduction of dark yellow, followed by a lighter counterpart. At this juncture, all 10 screens have played their part in the intricate dance of colors: light and dark pink, light, medium, and dark green, light and dark purple, red, and light and dark yellow. This printing machine, with the capacity for up to 16 colors, showcases its prowess in the realm of flatbed printing. The elongated bed allows for the incorporation of multiple colors, offering a rich palette for designers. The fabric, now adorned with a total of 11 colors, including the pristine white and brown, reflects the craftsmanship of this intricate process. While this machine has the potential for even more colors, the artistry displayed in this particular print stands at an impressive 11. The journey through screens, with its meticulous dance of colors, encapsulates the essence of fabric printing, a harmonious blend of creativity and precision. However, fabric printing isn't confined to the realm of flat screens alone. There exists another fascinating technique, rotary printing. In this method, a cylindrical screen, rolled into a tube, facilitates larger production runs and designs that pose technical limitations on flat screens. The rotary machine, with the ability to print 15 colors, operates at a brisk pace, occupying less floor space than its flatbed counterpart. The rotary printing machine introduces colors sequentially: black, blue, red, light blue, orange, yellow, and purple. Unlike flatbed printing, rotary printing ensures complete coverage of the white fabric, leaving no traces of untouched areas. The fabric, adorned with a myriad of colors, undergoes a drying process before being neatly folded and awaiting the final finishing touches. The finishing process is a crucial chapter in the fabric's journey, beginning with steaming. Steaming is not merely a step, it's a transformative process that fixes the reactive dyes onto the fabric. Without this crucial step, the colors would merely wash away. The high-temperature steam catalyzes a chemical reaction, rendering the colors permanent and ingrained in the fabric's fibers. Following the steaming process, the fabric embarks on a voyage through what can only be described as the world's largest washing machine. This expansive washing line features multiple stations, each with varying water temperatures and chemical compositions. The fabric undergoes a series of dips, progressively moving through stations with increasing water temperatures and decreasing chemical concentrations. This meticulous washing ensures the removal of any excess dyes, guaranteeing the fabric meets stringent color fastness standards. The washing line, akin to other sections of the factory, emits steam as the fabric undergoes its transformative journey. Finally, the fabric is dried on large heated metal rolls, bringing it to a state of completion before moving on to inspection. In the realm of fabric production, attention to detail is paramount, yet the inevitability of defects looms. Printed fabric defects can arise from various factors, and there are weaving defects that may have persisted from the initial stages. Some factories opt to inspect and roll fabric simultaneously, while others prioritize inspection before rolling. The meticulous inspection process ensures that only flawless fabric makes its way to consumers. In this particular factory, with over 800 dedicated workers, the output is nothing short of impressive: almost 5 million yards of fabric each month. This translates to over 330,000 bolts of fabric, a testament to the scale and efficiency of the operation. The final chapter in this intricate journey involves sealing the fabric rolls. A sealing machine expertly wraps each roll in plastic, lifting it to seal the ends securely. The sealed rolls are then carefully placed on large pallets, destined to be transported for export. These rolls, containing the vibrant culmination of colors and craftsmanship, embark on a journey from Asia to the US, eventually gracing the shelves of local fabric stores.